Okay, just like before, for this practice, I'd like you to try them on your own before you watch the video, just to see if you're understanding the steps as we go. This does say find all solutions on the interval 0 to 2 pi, and so we're going to have maybe more than one answer here, but we won't have the plus 2 pi n at the end of our final answer. So again, when we see that the variable has a coefficient, that the angle has a coefficient, we're going to want to substitute it out. And so I'm going to rewrite this as, well, I'm going to go ahead and write r is equal to 2x. So the cosine of r equals radical 2 over 2. That means that r must equal, I would say, pi over 4 plus 2 pi n, and r equals 7 pi over 4 plus 2 pi n. We're going to substitute back out the r and put 2x back in its place. So 2x equals pi over 4 plus 2 pi n, and 2x equals 7 pi over 4 plus 2 pi n. We're going to divide both sides by 2, or even better, multiply by 1/2. And that leaves us with x equals pi eighths plus pi n. And over here we have x equals 7 pi eighths plus pi n. Now, if we were asking for just the general solution, we'd be done, but this one is asking us for all solutions on the interval 0 to 2 pi. And so we're going to have to keep adding this pi to each of our answers until we start getting answers that are greater than 2 pi. So pi over 8 is one of our answers, obviously, because that's less than 2 pi. But now we've got to add pi over 8 plus pi. I can rewrite pi as 8 pi over 8. That's still equal to pi, and that gives us 9 pi over 8. That I know is still less than 2 pi. Let's see if we can add any more. 9 pi over 8 plus another 8 pi over 8 gives me 17 pi over 8. That's a little bit too big because that's equal to 2 and 1/8 pi. So that's too big, so we're going to not worry about that when these two answers come from there. From our second answer, 7 pi over 8, that's already an answer. We're going to add 7 pi over 8 plus another pi, because it says 7 pi over 8 plus plus an additional pi. And so I want to go ahead and put 7 pi over 8 plus pi, and I can rewrite pi as 8 pi over 8, and I get 15 pi over 8. Hopefully you can see that if I did another, let's say I added another pi, so another 8 pi over 8, because that's just equal to pi, but now it has a common denominator, I'm going to get 23 pi over 8. That's almost equal to 3. That's equal to 2 and 7 pi over 8, 2 and 7/8 pi. And so that's too big as well, so I don't need those. These are my four answers, 1, 2, 3, 4, to this question. Last example, and this will be the one that challenges us the most, but we can take care of business here, I'm sure of it. So same thing, again, our trig equation has a coefficient on the variable, so we're going to substitute that out. We're going to say that r is equal to 4x. So we've got the cosine of r is equal to negative radical 3 over 2. Feels like to me that r would equal first of all, 5 pi over 6 plus 2 pi n, and r equals 7 pi over 6 plus 2 pi n. Substitute back in the 4x for the r, so it's 4x that equals 5 pi over 6 plus 2 pi n, and 4x that equals 5 pi over 6 plus 2 pi n. This gives us x is equal to, I'll go ahead and multiply by 1/4 on both sides. And we're left with x equals 5 pi 24ths plus 2 pi n over 4. The 2 and the 4 could reduce to 1/2, so really we've got just pi halves times n. I'll write the n out as a variable after a coefficient there. Over here we have x equals 5 pi. Wait, sorry, I made a mistake a while back. You guys probably caught that but couldn't say anything because I'm not there. That was 7 pi. This is 7 pi 24ths plus pi halves n. And so this is the general solution here. And so that's what we would ask for there. But this one does ask for all the solutions on the interval 0 to 2 pi. And so we have to keep going until we get something that is bigger than 2 pi. So 5 pi over 24 is fine so far. But now we need to keep adding pi over 2 n until we get to angles that are out of that interval 0 to 2 pi. So I'm going to erase this for now because it was useless to us down below. So I'm going to have to keep doing this. So 5 pi over 24 plus pi halves. I'll go ahead and make that into a common denominator. So that would be 12 pi over 24. So I get 17 pi over 24. It should be clear that's less than 1 whole pi, so that's still a solution. Now we'll take 17 pi over 24 and add another 12 pi over 24. That's 29 pi over 24. That's still less than 2 pi. And let's see, I'll do 29 pi over 24 plus another 12 pi over 24. And again, that 12 pi over 24 is coming from the pi over 2. We're supposed to keep adding pi over 2's until we get an angle that's past 2 pi. So this one is 41 pi over 24. I would hope you recognize that we're going until we get to 48 pi over 24, because 48 pi over 24 would equal 2 pi. And so we're looking for angles that are less than that. Hopefully it's clear that if I added another 12 pi over 24, I'd end up at 53 pi 24ths, and that would be too much. So we're done there. Now we got to also deal with the 7 pi over 24 and keep adding pi over 2 to that until we get bigger than 2 pi. So 7 pi over 24 plus pi over 2, which again can be written as 12 pi over 24, so I have a common denominator. That's 19 pi over 24, still less than 2 pi. Take 19 pi over 24, add another 12 pi 24ths. We've got 31 pi over 24. Take that one, 31 pi over 24 plus 12 pi over 24, and we've got 43 pi over 24. And hopefully again it's clear that if I add another 12 pi over 24 to that, I'm going to end up at 55, which is bigger than 48, so that'd be bigger than 2 pi. So these are our 8 total answers to this question. I know it was daunting, but there won't be many like this. This was really as challenging as we'll get with these ones, and I wanted to step you through it and show you that you can do it.